In this tutorial, I'll recreate a project I originally learned from a masterclass by Oscar Pettersson at Motion Design School, but this time entirely inside Blender instead of Cinema 4D. If you're ready, let's dive into Blender and make this project from scratch. Hello everyone, and welcome to this tutorial where we will learn how to create an infinite loop animation in Blender. Before we jump into Blender, there are a few basic principles we need to understand to achieve smooth, infinite loop movement. First, we need to use even numbers, preferably integers without fractions, to make the calculations easier. Additionally, the first and last frames of the animation must be identical. For the movement to be smooth, before finalizing the render, we will delete one frame to avoid repeating frames like the first frame, frame 0, and frame 56. So if we delete one, we will be left with 55 frames. Before we proceed with the first step of creating the loop in Blender, it's important to note that a good animation requires time and effort. So don't rush to get the result. Instead, try multiple times, and don't be afraid to experiment until you get the desired outcome. One last thing to mention is that I assume you have a basic understanding of the Blender interface and how to navigate it. If you're not very familiar, don't worry, I'll explain everything step by step, and I'll show any relevant shortcuts on screen in case I forget to mention any. Now let's begin the first step of creating the loop. Start by going to File, New, General to create a new file. After that, we will go to Edit, Preferences, then select the Animation tab. In the F-Curves section, set the default interpolation to linear instead of Bezier, then save the preferences. Next, go to Output and set the frame rate to 30 frames per second. These are the initial steps we need to follow. Next, let's create a new object. Simply press Shift plus A, and you can choose to add either a circle or a cylinder. I will choose the cylinder and increase its vertices count to create a smoother shape. I'll set the radius to 2, but you can increase it if you want. However, we'll be adjusting the equation later. Set the depth to 1. Next, press R then X to rotate the object 90 degrees. Press Tab to switch to Edit mode. Then press 3 to go to Face Select mode. Select the first face, then hold Shift and select the second face. Press I to create an inset with a value of 0.3. With the faces still selected, right-click and choose Bridge Faces to connect them like this. Switch back to Object mode. Next, go to the Modifier tab. I will add the Bevel modifier from the Generate section. I will set its amount to 0.5 and the segments to 5. Then right-click on the object and select Shade Auto Smooth. Now I want to move the object, but I don't want to move the main body itself. Instead, I want the object to stay in place, so I will use an empty object as a parent to move the cylinder. To do this, press Shift plus A and add an empty object. Link the cylinder to the empty by selecting the cylinder, then holding Shift and selecting the empty, and pressing Ctrl plus P to parent them. There's an easier way to do this. I can select the cylinder by holding Shift and clicking on it in the outliner, then simply drag it onto the empty and release it. You can move the cylinder by moving the empty object. See which one works better for you and use it. Next, I want to raise the empty along the Z axis. First, let's call it Wheel. Now I will go to the Object Properties. Remember, I'm not moving the cylinder. I'm moving the empty. The cylinder can be changed to anything else. I'll choose the Wheel empty. I want to raise it by approximately 2 meters on the Z axis. Why am I doing this? I want to raise it by 2 meters, which is the radius of the circle. Press 1 to go to the front view. I want to move the wheel from here to here, but I want to move it while it's rotating 360 degrees. So, how will I know the distance it will cover while it rotates 360 degrees? In order to know the distance, I need to calculate the circumference of the circle. The circumference of the wheel is calculated by a formula that says C equals 2 times pi times r, where r is the radius. Pi is approximately 3.14. So we know that the radius of this circle, or wheel, is 2. Let's get the calculator. We have a radius of 2 times 2 times 3.14, which gives us C equals 12.56. Now let's round this number to 12.6, and I want you to memorize this number because we'll need it often, along with the radius. Okay, now I will go to the timeline and make it a little bit bigger, set the end at 56 frames, and ensure that I am at the first frame. I want to select the wheel empty, then go to the location X. Either I will put the keyframe on the point here, or I will right-click and select Insert Single Keyframe. I will go to the last frame, 56 of the movement, enter 12.6 in location X, which is the distance the circle travels, and insert the keyframe. I want to make sure that these two keyframes are set to linear. So I will select them or press A on the keyboard, then press T and choose linear. I will press play to see the animation. It looks great. Now we need to handle the rotation. I will go back to the first keyframe, ensure it is on the first frame, then go to Rotation Y and set the value to 0. I will right-click and select Insert Keyframe. Then I will go to the last frame, set the rotation to 360 degrees, and insert the keyframe either from here or from the right-click menu. Now I will check the movement to see if everything is working fine. However, I need to make sure the frames are also properly adjusted. I will select the keyframes by pressing A, then right-click and choose from the menu Interpolation Mode and select Linear. This way, you will notice that the movement has improved. To clarify the rotation of the cylinder, select the cylinder and add a material from the Material Properties. Then go to the base color, click on the input, and add a checker texture. After that, reduce the scale to 2 to make the result fit better on the cylinder. Let's go back to the beginning of the animation and play it. You'll notice that it rotates and everything is good. Now, we want to add a new collection to the scene. Click on the icon above and name it Camera. Then press Shift plus A to add an empty and name it Dolly. On the first frame, we want to insert a keyframe, so we will go back to the Object Properties. On location X, we want to right-click and insert Single Keyframe. On frame 56, we know that the circle or cylinder rotates 360 degrees and covers a distance of 12.6 units during its rotation. So, I set 12.6 on the last frame and insert a single keyframe by clicking here or by right-clicking. Make sure both keyframes are linear by selecting them, then pressing T and choosing Linear. I'll go back to the first frame, press Shift plus A to add a camera, then parent it to the dolly empty by selecting the camera, holding Shift, dragging it onto the dolly empty in the outliner, and releasing. Now, I'll enter the camera by clicking on the camera icon. This will take me into the camera view. I'll enable the view navigation by clicking the lock and using the mouse scroll to zoom out until the wheel appears. Then I can return the lock and zoom in. It will zoom the camera in the viewport. You can also press 0 on the numpad to enter the camera view. To adjust the camera again, I click the lock. Next, I'll go to the camera properties and set the focal length to 135 millimeters. While adjusting the camera, it might move unexpectedly. To fix this, I'll select an object in the viewport to make it the center. This way I can move around and adjust the angle easily. Now, let's play the animation and see if it's good. The animation's perfect. I'll switch back to Solid View, and then I'll go to the front view. Now, let's go back to the first frame. We want to add the arm, but first I'll add an empty and name it Arm GSR. You'll notice that the empty is in the camera collection. I don't want it there, so I'll move it to the scene collection. I can deactivate the camera here because I don't need it right now. Now, I want to raise this empty in the middle. I'll go to the properties and adjust the location on the Z-axis to 2, which is the radius of the circle. It is now in the center of the wheel, and now I want to move it to the right by setting the X-axis to 1.3. Now you can notice the change. I'll switch to the front view and notice the position of the empty. Then I'll add a plane by pressing Shift plus A. Then I'll press RX90 to rotate it and name it Arm. After that, I'll adjust its dimensions by pressing N on the keyboard. The properties appeared, and in the dimensions, I want to change X to 5 meters and Y to 1 meter. and I want to add a bevel to the edges. I'll press N here to exit this panel, then go to the modifiers, and in the modifiers, I'll add a bevel. We'll notice no bevel effect, even if we increase the amount. To fix this, let's go to the vertices. The bevel looks stretched because the scale isn't 1 on all axes. Press N to check the scale. Then press Ctrl plus A and apply the scale. After that, the bevel looks much better. I'll set the bevel amount to 0.5 and the segments to 10. Now, I want to add thickness to the object, so I will go to the modifiers. Under the Generate section, I will add a Solidify modifier. I'll notice that the Solidify modifier adds thickness in one direction, so I'll set the offset to 0, and the thickness will be applied in both directions. I'll also set the thickness value to 0.4. Then I'll right-click and choose Shade Auto Smooth. This will make the object smoother, but we'll notice that this line appears here. If I go to the Overlays and enable the wireframe, I'll find that the reason is the bevel segments are stacked on top of each other. If I reduce the amount value, we'll see that the edges look like this. To fix the issue, I'll add a Weld modifier. We'll notice that the problem is gone, and the result is excellent. I'll add a bevel to smooth the edges using the Bevel modifier under the Generate section. I'll set the amount to 0.02, and then I'll set the segments to 5, like this. Now, I'll switch to the front view by pressing 1 on the numpad, and I'll add an empty to parent the arm to it. So I'll press Shift plus A and add an empty, then I'll move it by pressing G and X to position it here, and set the value to -2. To make the empty appear behind the object, I'll go to the empty's properties and scroll down to the Viewport Display section. Then I'll select In Front, and I'll notice that the empty now appears in front of the object. Then I'll select the arm in the outliner, press Shift, drag it, and drop it onto the empty. This will parent the arm to the empty. I'll rename the empty to Arm, and then parent this empty to the Arm GSR empty. There are two ways to parent the object. First, to match the X value and Z value from the empty. Then, select the empty where you want to transfer the coordinates. You'll notice that the empty has moved to the same coordinates. The second method is easier than the first. You just need to enable the Copy Attributes add-on from the Preferences. Then I'll select the Arm empty, Shift-select the Arm GSR empty, press Ctrl-C and choose Copy Location. While the two empties are still selected, press Ctrl plus P and choose Set Parent to Object. Then I'll parent the Arm GSR empty to the wheel empty. First, I'll hide this empty. Then select the Arm GSR, Shift-select the wheel, and press Ctrl-P. Then I'll choose Object. We'll notice that the parenting has been applied. I'll switch to the front view by pressing 1 on the numpad. I'll press Shift plus A to add a new empty and name it Aim. And I'll move the empty on the X-axis to 6 meters, for example. And I'll move it up on the Z-axis by pressing G then Z, setting it to 2 meters, for example. From the top view, I'll select both empties, Aim and Arm GSR. And I'll move them on the Y-axis to create some distance from the wheel. For example, by a value of 1. To give the same value to the other empty, select it and set the same value. Or I can select both empties, set the value to 2, hold down Alt, and press Enter to apply the same value to both. I will undo because I want the value to be 1 for both. I want the Arm GSR empty to continuously look at the Aim empty while it moves, maintaining its orientation towards it throughout the animation. I will select the Arm GSR empty, then go to the Constraints tab and add a track to constraint. Then I'll select the target from the viewport and choose the empty object. We'll notice that the arm's direction is now incorrect, so I'll select the track axis and set it to the X-axis. I'll set the up axis to the Z-axis. If you select the aim and move it by pressing G, you'll notice that the arm follows the aim. I'll go to the front view and move the aim down on the Z-axis like this. and you'll notice that when I play the animation, the arm will always follow the direction of the aim. I'll set the Z value of the aim back to its original value. Now I'll add an object inside the wheel at the center, so the 3D cursor must be at the center. If the 3D cursor is elsewhere, I can select the wheel or any object I want to center the cursor on, then press Shift+S. Then I'll choose Cursor to Selected, and you'll notice that the cursor is now perfectly centered. I'll go back to the front view. I'll add a cylinder. I need it to have 64 vertices, with a radius of 1.7, and I will explain why, and a depth of 0.8. The radius is 1.7 because, if you recall, the wheel has a radius of 2 meters, and we subtracted 0.3 for the inset, so the remaining value is 1.7. That's why I chose this value to perfectly fill the center of the circle. While the cylinder is still selected, I'll press RX90 to rotate it by 90 degrees. I will name the cylinder Ring. Then I'll press / to view the cylinder alone in local view. I'll press Tab to enter edit mode, then select the face selection icon here, and choose this face and Shift+ select the other face. I'll press I to inset with a thickness value of 1. While both faces are selected, I'll right-click and choose Bridge Faces. I'll exit edit mode by pressing Tab and exit local view by pressing /. I'll press Alt+Z to toggle X-ray mode, and I want to create a hole in this area. I'll add a cylinder with the following dimensions: 34 vertices, a radius of 0.2, and a depth of 1. Then I'll press RX90 to rotate it. While the cylinder is selected, I'll press Shift and select the empty, then press Ctrl+C and select Copy Location. The cylinder will then move to the desired location. I'll switch to the perspective view, and I notice that the cylinder is a bit short. I'll press S then Y to scale the cylinder a bit along the Y-axis. I'll move it slightly along the Y-axis. I'll go to the top view, press G and Y, then move it by 1, for example. Now I will parent the cylinder to the wheel, so I will press Shift and select the empty for the wheel, and I'll press Ctrl+P and select Set Parent to Object. If I move it, the cylinder will move with the wheel. But notice that we forgot to link the ring with the wheel, so I will select it and then press Shift and select the empty for the wheel, and I'll press Ctrl+P and select Parent to Object. We will notice that the ring has been parented to the wheel. We will select the cylinder and name it Hole Cut. And with Shift, I will select the ring along with the cylinder and press / to view them alone. After that, I will select the ring, go to the modifiers, add a Boolean, and in the Boolean, I will select the object from which I will cut. So I will select Hole Cut from the outline, or I can select it from the viewport. We will notice that nothing happened because we need to hide the hole cut object. So we will get this result, and I want to make the hole cut shade auto smooth, and the same thing for the ring. And I will add a bevel to the ring here on the edges to make them smoother. I will go to the modifiers and add a bevel. I can increase the number of segments by 4, for example, and we will notice a slight distortion on the surface here. To fix this distortion, I will add a weighted normal modifier from the normal menu. So we see that the distortion disappeared, and I can adjust the bevel value a bit. So I will notice that the bevel value is not changing, so I will go to the geometry section here and uncheck the clamp overlap option. Then I decrease the amount value, and you will see that I can now control the bevel amount easily. Exit local view, then I will go to front view. I want to add a cylinder in the area where we made the cutout. So I will make the hole cut object visible. Then press Shift+D to duplicate it. I will rename the duplicated object to InHole. I will then shorten its length a bit by pressing S then Y and set the value to 0.6. After that, I will hide the hole cut again and disable the ability to select it. I will select the InHole object, go to the Modifiers tab, and add a bevel modifier. The bevel value is too large, so I will set it to 0.02 and increase the segments to 4. I want it to be a bit longer on this side. I will go to Top View, press S then Y, and stretch it a bit. I will set the value to 1.6, for example. You will notice that the bevel is now stretched along the object. I will press N and I will find that the scale values are not all 1. To fix the issue, as we are used to, we will press Ctrl plus A and select Apply Scale. I will go back to Top View, press G, then Y, and move it a bit like this. By 0.4, for example, I will switch to Perspective View, and we will see this result, and everything looks good. I will go back to Top View again. I will select the in-hole and create a copy by pressing Shift plus D and GX and drag it over here. Adjust the value to 5.3. I'll check if the position is correct from front view. Nice. I'll go back to Top View. It's too long, so I'll shorten it a bit to 0.5, for example, and I'll adjust its position a bit. Let's make it 1 on the Y axis. I'll make sure there is enough space between it and the wheel to avoid any collision during the movement. I can shorten the length a bit, but I think it's fine as is. Press Ctrl plus A and apply the scale. To ensure the bevel effect is applied correctly, we notice that the cylinder is not parented to the arm. I'll go back to the first frame and switch to front view. So I will select the cylinder. Then Shift plus select the arm, press Ctrl plus P, and choose Set Parent to Object. With this, the cylinder is now parented to the hand. Now I will select the wheel and increase the bevel a bit. Let's set it to 0.5. We'll notice a visible line here, so let me show the wireframe to see it. As we mentioned earlier, this is caused by bevel artifacts due to overlapping segments in the bevel. I'll set the value back to 0.5 as it was, and then I'll add a weld modifier. It should be placed after the bevel modifier. If I hide the wireframe again, we'll find that the bevel artifacts have disappeared. I notice that the edges appear broken or not smooth. This can be fixed by increasing the bevel segments to 10, for example. I recommend not increasing the segment count too much, as it could affect the smoothness of the animation and slow down the scene during preview. Later, we can apply the modifiers or temporarily disable them to make the scene lighter, and therefore the animation will be smoother. I'll switch to front view. Before we continue, let's save the file we're working on so we don't lose our progress. Go to File, then Save As, and choose the location where you want to save the file. I'll create a new folder and name it MDS-Loop Animation. Inside the folder, I'll name the file animationloop.001. Then I'll click Save. Later, I'll save through File, Save Incremental, or using the Ctrl-Alt-S shortcut. Now I'll create a floor for the rotating wheel to roll on, and we'll add the hook that will attach to this part. I want to make sure the 3D cursor is at the origin. Press Shift-S and select Cursor to World Origin. Press Shift-A to add a cube, then press N to set the dimensions we want. We already know that the distance the circle travels along the x-axis is 12.6. So I'll set the x value to 12.6 and divide it by 2 to get a suitable shape. And I'll set the z value to 1.5, for example. And I'll move the cube down on the z-axis by 1.5 divided by 2, so it sits on the ground beneath the wheel in the negative direction. And for the y value, I can set it to 3, for example. All right, I'll press N to hide the sidebar. And I'll name this cube Bridge. And from the modifiers, I'll add an array modifier. I'll need about 7 copies, but I can't see the edges of each copy. So I'll add a bevel modifier. Immediately, we'll notice a distortion in the cubes. So I'll press Ctrl-A and apply the scale. The bevel looks better now, so I'll increase the segment count to 3 and maybe decrease the amount to 0.05. So we got this result. I'll go to the camera by pressing 0 on the numpad. I'll unlock the camera and adjust the angle a bit. We can see that we need to add a cube in the empty space here. I'll go to the cube's properties, and for the x location, I'll set the value to -6.3, which is the length of the cube. I'll lock the camera again to prevent accidentally moving it. Now I want to move the aim down. I'll go to the front view, press GZ, and move it down like this. Now I want to create the hook object here to attach to this part. To ensure the shape I add appears in this place, I'll select the object, press Shift S, and cursor to selected, and the cursor will be in the right place. Now press Shift A to add a plane. Then RX to rotate it 90 degrees. Then press Shift plus Z, Alt plus Z to enter wireframe and X-ray mode. Press Tab and 1 to enter vertex select mode. I will select this vertex, press X, and then delete vertices. Select the two vertices below and move them up like this. Then I will select these two vertices, GX, and move them like this. And select this vertex and move it down a bit. Select this vertex to extend the shape a bit. Like this, and I'll name it Hook. Select all the vertices of the shape or press A on the keyboard. I'll switch to perspective view. I'll press E, then Y to extrude along the Y axis in this direction by minus 0.3, for example. Then I'll exit X-ray mode to solid mode. Then I'll check to make sure the normals are facing the correct direction. We'll see that the normals are reversed and appear red. I'll press the / to isolate the shape, then enter edit mode. I'll select all the faces, then go to the mesh menu, normals, and choose flip. This will flip the normals, turning them blue, which is the correct direction. Then I'll exit edit mode, switch from wireframe mode to perspective view, go to the overlays, uncheck face orientation, and return to front view. To give the shape some thickness, I'll go to the modifiers tab and add a solidify. I'll set the value for the solidify modifier. From the front view, I'll notice that the thickness isn't even. I'll check the even thickness option. I'll reduce the thickness value, maybe 0.2 would be good. I'll set it to 3. I want to round the corner here. I'll temporarily disable the solidify modifier. Then I'll add a bevel modifier to round the corner. I'll move it up and place it before the solidify modifier. I'll check the result from the front view, and then I'll adjust the bevel value to around 0.2. I'll set the segments to 10. This will give us this result, and then I'll reactivate the solidify modifier. I'll select the hook and move it a bit along the y-axis. Like this, then I'll switch to the right view and we'll see that the hook looks a bit thick. So we can decrease the thickness in edit mode by selecting all vertices. Or we can select only the edge vertices, then use G plus Y and move by 0.1. Then we switch to right view to see the result. Great, I will add a bevel modifier to smooth the edges. The bevel value is too high, so I will reduce it to 0.2. I will set the segments to 4 divisions. After that, I will right-click and choose Shade Auto Smooth. The last step is to check if the scale of the hook is correct. I will press N and verify that everything is fine. One more thing remains, making sure to set origin to geometry. I will switch to camera view by pressing 0 on the numpad. I want to create a second copy of the hook here. To find the correct distance, if you remember, the wheel moves 12.6 units per rotation. So I'll go to the Properties panel and check the X location, which is 5.92. I'll remember this value. Now I'll press Shift plus D to duplicate the hook. I'll go to X location and find the same value. I'll then add plus 12.6 to this value, which moves the new hook to the correct position. To confirm its position, I'll switch to camera view and observe its movement with the camera. That's exactly what we want. Now I'll animate the aim movement. I'll switch to front view. At frame 1, I'll set a keyframe on X location. At frame 56, I'll add another keyframe, increasing the X value by plus 12.6. I will check the movement. Great! Sometimes I may notice a drop in frames and the playback doesn't show 30 frames. In this case, I can either apply the modifiers to the objects if I'm sure I won't need to make further edits, or I can disable the modifiers temporarily and then enable them again before the final render. I will switch to camera view, then hide the overlays. Now, I need to make sure that the first frame and the last frame of the animation are aligned perfectly. I'll go back to front view and enter X-ray mode and wireframe mode, or from these icons. I'm going to add easing to the wheel's movement because its current movement is linear, meaning the acceleration is constant. I will select the keyframes in the timeline. As you can see here, we have two channels, X location and Y rotation. I will double check the selection, then press T on the keyboard and choose Bezier. I can also press Ctrl plus Tab to switch to the graph editor, or I can choose the graph editor from this icon. Now I'll see the two channels or axes, X location and Y rotation. I will press A on the keyboard and dote on the numpad to frame the selected curves. I'll notice that they are linear, as you can see. There's a horizontal blue line which represents the 3D cursor, but I don't need it right now, so I'll hide it. Then I'll press N to hide this panel. I'll select the curve, then press T and choose Bezier. Now the movement has easing, with acceleration and deceleration. It accelerates at the start, reaches the highest speed in the middle, and then slows down towards the end. I want to hide the arm and its contents so I can see the wheel's movement alone. Therefore, I'll quickly organize the files and rename the objects here. I've finished organizing the elements in the outliner. Now I can select the arm GSR empty in the outliner and hide it, but it will hide only the empty. So I will press Shift and then click on the hide icon here in the outliner. This will hide the arm and all its children. I will press play to preview the movement. Perfect. Now I want to add overshoot to the wheel's movement to make it slightly go beyond the last frame. I will go to frame 42, for example, and then I will select the X curve, press I, and choose only active F curve. It will add a keyframe to the selected curve. Then I will do the same for the Y rotation curve. I will press normalize and I'll find that both curves now have keyframes. One thing I like to do is hide the handles for all keyframes. To do that, I will go to the View menu in the Graph Editor and choose Only Selected Keyframe Handles. This will display the handle only for the selected keyframe. I will turn off Normalize and then resize the Graph Editor a bit. I will select the Y rotation and raise the value of keyframe 42. But before that, I will press N to display the F curve properties. I will make sure I have keyframe 42 selected. In the Properties panel here, I'll notice that I'm currently on keyframe 42, and its value is 302. I already know that the last keyframe in the movement has a value of 360 degrees, so I want to raise the value of keyframe 42 to 370 degrees, for example. Then select the X location, press A, then period key to frame the selected curve. I know that the last frame is 12.6, so I will raise keyframe 42 to 13. Let's set it to exactly 13. And now I have the overshoot that I wanted. Let's preview the animation. Observe how the wheel's movement exceeds the value and then returns back. I've got a great movement now. Okay, select the curves, press A, and period on the numpad to frame it. I'll go back to the first frame and reveal the arm by pressing Shift and the eye icon. Now, I'll expand the window a bit and start animating the aim empty. But first, I'll delete the last keyframe. I can go to the timeline to double check. Also, I would like to delete the first keyframe too, and I will add it later. I'll select the empty and want to place it in the center of the end object. If the cursor isn't in the center of the end object, for example here, while the end object is selected, I'll press Shift S and choose Cursor to Selected. Then I'll select the Aim Empty, Shift select the end object, press Shift S and this time choose Selection to Cursor, so the aim will move to the center of the end object. Now make sure to be on the first frame of the animation, then add a keyframe on X and Z location. I'll reselect the wheel empty and Control Tab to go to the graph editor. I'll notice that while the wheel moves, the hand moves forward with it. I want the hand's movement to stay fixed in place and have rotation applied backward, or what's called drag in animation, meaning a delay in the movement. So I'll select the Y curve here or from here. I'll press A to select all the keyframes of the curve. Then I'll go back to the first frame of the animation and adjust the curve in the Y-axis upwards, roughly to 34. I want the hand to stay in place until around frame 12. I'll select the F curve, press I on the keyboard, and choose Only Active F curve. It will add a keyframe here. I'll also add a keyframe to the X curve. So I'll select the curve, press I, and choose Only Active F curve. I'll now go back to the Y rotation curve. If it's not visible, I'll press A, then press period on the numpad. It will now appear fully. Now I'll press N to hide this panel. I'll move keyframe 12 up until it looks right. The hand is in place, but the curve needs some tweaks. The movement is stable at keyframes 1 and 12, but the middle needs adjustment. I'll adjust the curve until I get a satisfying result. I'll speed up the video a bit so you don't get bored. After adjusting the curve, I got the result I wanted. And don't forget, animation takes a lot of time and adjustments to get satisfying results. You can save the file now and come back later to make adjustments with a fresh look. Let's watch the animation after the adjustments. The animation is great, but we need to move the aim empty since it's staying in place. I'll select it, then go to the timeline. I want to keep the movement stable until frame 13, so I'll drag the first frame, press GX to frame 13. I'll make the starting point of the aim empties movement from here. The end of the animation will be at frame 56. I'll zoom out the graph editor a bit. As we know, the wheel covers a distance of 12.6, so I'll add the value of 12.6 to the last keyframe's value. I'll make sure I'm on the last frame. Then I'll copy the first frame to the last frame, and after that I'll add 12.6 to the X value. Then I'll add a keyframe, then I'll preview the animation. After that, I'll go to the camera view to make sure that the first and last frames of the animation are the same. Nice, the first and last frames are the same. Next, we'll adjust the arm movement so it raises and hits the ground. To create that animation, I need to go back to the graph editor, so I'll press Control Tab. Then I'll go to the front view, and I'll select the Z axis from here. At frame 47, for example, I'll select the curve, press I on the keyboard, and choose Only Active F curve to add a keyframe at this point. I'll zoom in, and while the keyframe is selected, I can set the value I want for the Z axis here. Let's say 2, for example, and add a keyframe here. And I'll press A, then period to frame the keyframes. I can reduce the value by pressing G and Y. Then I'll select all the keyframes, press T, and choose Bezier. I'll preview the movement, but there's an issue with the rotation. This is because we also need to smooth the X-axis. So I'll select the X curve from here. If it's not visible, I'll press A, then press period on the numpad. I'll select all the keyframes and change them to Bezier. I'll select the handle of the first keyframe and raise it up to make the movement faster at the beginning, like this, and then I'll go back to the Z curve. Great, our animation is good, but we need to adjust the Z axis a bit. I'll press A, then period on the numpad. We want the movement at frame 47 to drop with more force, but I think we need to raise the keyframe a bit. I'll press G, Y, and lift it, maybe by a value of 2.5, for example, and press here to add a keyframe to get a sharp drop for the hand. I'll grab the handle of the last frame and rotate it like this. Or, while the keyframe is selected, press V to choose the handle type as vector or free. To separate the two handles, select this handle and lift it up to adjust the curve like this. This creates a sharp drop in the arm. See how it drops? Boom. Boom. I'll scale the curve here with S like this to make the arm hang in the air a bit. I can see the motion path in the viewport, so I'll go to the properties here, then scroll down to motion paths, select calculate, and choose calculate. And I will see the motion path. I can move the last frame one frame back. I'll press G, then X. I'll check how the movement drops. To view the movement more clearly, I'll switch to the camera view and I'll see that the movement is perfect. If the motion path isn't showing up in the viewport, I can go to the overlays section and enable the motion path here so I can see it. Now I'll hide the overlays from the scene and make sure that the first frame and the last frame of the animation are the same. The animation looks great. Let's go back to the front view. I think I don't need to see the motion path, so I'll delete it. I'll adjust the movement again. I want to make sure there's no sliding in the wheels movement here, and I'll refine it by tweaking the X and Z curves as needed. I'll speed up the process so you don't get bored. Great, I finished adjusting the animation and we got the result we wanted. Now I'll move on to completing the creation of the scene. Now I'll exit the camera view. I want to create a background and a floor for the scene, so I'll shrink the windows to give myself more space. I will switch the graph editor to a timeline and resize it like this. First, select the bridge object in your scene, then press Shift-D to duplicate it. If your scene ends up tilted like this, you can switch to any orthographic view and simply pan using the middle mouse button, and it will snap back and straighten the view for you. Now move the duplicate along Y-axis with GY, rename it to wall, and temporarily disable the array modifier, then edit the wall object as needed. I will do it fast. Now I'll enter camera view and re-enable the array modifier. I'll check the first and last frame, then rotate the wall a bit to add some movement. First, let me apply the array modifier. Next, I'll enter edit mode and press A to select the entire shape. To separate each wall, I'll press P and choose separate by loose parts. I have separated each wall as you can see. With all walls selected, right-click Set Origin, then choose Origin to Geometry. Now each wall has its pivot point in the center. I'll go to the properties and I want to rotate each one on Y. If you notice, the rotation happens for just one wall. I want to rotate all of them at once, so I'll enter a value here, let's say 18 degrees, and I'll hold down Alt before pressing Enter. They will all rotate, but I want them to rotate in the opposite direction, so I'll enter -18, then hold down Alt and press Enter. Now, I can go to the Transform Pivot icon and choose individual origins. Then I'll scale them on the X-axis, for example, and adjust the size a little to avoid overlapping. I'll switch to the camera and scale the walls along the Z-axis like this. Then I'll check the movement and make sure the first and last frames are the same, using Shift plus left arrow and Shift plus right arrow. Now I'll exit the camera view, select the bridge, duplicate it, and move it down along the Z-axis, GZ. I don't need the array, so I'll delete it. Then I'll enter edit mode and make adjustments to the shape like this. It looks great. Now I'll create a new empty object, add all the walls inside it, and rename it to back wall. By holding Shift and clicking on the icon, I can hide and show the back wall. We're almost done with this stage. Now we'll create a new collection and name it BKG and start organizing the outliner a bit. You can make adjustments to the objects in the scene as you see fit. Great achievement. I'm really happy with the result we've reached together. Now let's do one final check on the first and last frames of the animation. Everything looks great, and you can make any adjustments or add more details to the scene if you'd like. The first thing we need to do is make sure we're using Cycles as our render engine and set the device to GPU compute. Next, in the sampling section, set the viewport max samples to 128. Also set the max samples for the final render to 128 as well. That will be enough. Now scroll down, keep the view transform on AGX and the look on high contrast. We can increase it if needed. The higher the contrast, the better the colors will appear. Now let's move over to the Edit menu, then Preferences. In the System section, I'll select Optics as the rendering device since I have an RTX 4060 GPU on my laptop. Then in the Add-on section, I'll enable the Node Wrangler add-on, as it will assist with the materials. After that, save the preferences and close the window. I'll split the view into two. This one will be for the camera. I'll hide the gizmo from here and also hide the toolbar by pressing T. Then I'll switch this view to the shader editor and hide the sidebar with N. Now I can see the material we used earlier to check the wheel rotation. Since I don't need it anymore, I'll select it and press X to delete it. Then I'll switch to render mode so I can start working on the lighting. I'll switch from object to world in the editor to start adding the lighting. If you set the background strength to 0, the whole scene will turn dark. Now select the background and press Ctrl+T. This will add an environment texture node. Make sure the Node Wrangler add-on is enabled for this to work. Next, click Open here and load an HDRI. Locate the folder where your HDRI files are. I have this free pack and I'll share the link in the description. I'll select this HDRI and then click Open. I still can't see it because I need to bring the background strength back up. I will set the value to 1. You'll notice the scene becomes brighter, but I need to rotate the HDRI on the Z-axis in the mapping node to get better lighting. I'll rotate it 90 degrees. I notice the effect is still weak, so I'll increase the value to 140 or 150. The lighting looks better now, but it's a bit harsh, so I'll reduce the strength to 0.8. I'll exit from the camera view and switch to perspective. I'll select the walls from the outliner, then press G and Y and move it like this. I'll go back to the camera view. You'll notice there's a shadow in this spot and I don't want it here. So I'll go to the mapping node and adjust the rotation to make the shadow fall on the ground like this. I'll increase the strength to 1.5. The lighting looks good now, but later I might add an area light to improve the scene. Now I'll go back to the object. We'll start by creating the material. I'll select this object and add a material by clicking New. The principled BSDF will show up. I'll start by pressing Shift+A and adding a color ramp. Then I'll make a copy. Then I'll press Shift+A to add a noise texture. I'll also add a gradient texture. I'll connect the factor from the noise texture to the factor input of the first color ramp, and then connect the color output to the base color. And I'll connect the factor from the gradient texture to the factor input of the second color ramp. To control the scale, rotation, and position of the noise texture, I'll press Ctrl+T, which will automatically add both a mapping node and a texture coordinate node connected to it. I'll do the same for the gradient texture. Now there are 2 texture coordinates, but I only need 1, so I'll delete the extra one. And I'll connect the object output to the noise mapping node and the generated output to the gradient mapping node. I will make some room here and adjust the windows a bit. Now I'll adjust the noise texture settings. I'll leave the scale as it is, and I'll set the detail to 0.1 and the roughness to 0.4. To see the noise changes while the node is selected, hold Ctrl plus Shift and left click on the node. I'll leave the two other properties of the node as they are. In the mapping node, I'll tweak the noise size, making it bigger or smaller, for example, increasing it by 3. If I connect the mapping node to the generate here, I won't get the correct result on the object because I don't want to apply a UV, so I'll reconnect it to the object. I'll press Ctrl plus Shift and left click on the node to see its effect. Currently, the noise is only linked to the material, so I want to change its color through the color map. So I'll shift the black to 0.5 and turn the white into orange with this code, then set it to 0.7. I can always tweak the colors later if I need to. So I got this result. Now I'll go to the color map of the gradient and set the black to 0.4 and the white to 0.5, for example. Right now I can't really see the result, so I'll connect the color map to the base color here, and now the gradient shows up. Now I'll check the gradient alone. This is how it looks. I'll go back to the color map, adjust a bit, setting white to about 0.5 and black to around 0.4. I'll tweak the values based on what looks right. I want about half black and half white. I'll change the black to beige with this code and the white to dark orange with this code. Now it's about half orange and half beige. I could switch from linear to constant, but it would make the gradient too sharp, so I'll keep it linear. The result is good, but I want to check the effect of the gradient and the noise together. I want to blend the two color maps to see the result. I'll make some room, then press Shift plus A and add a mix color. Now connect the color map for the noise to the B input and the color map for the gradient to the A input, and the mix result output will go to the base color. This will give me this result. I'll set the factor to 1, change the blend mode to screen, and I'll notice that it gave me this result. I can adjust the noise size by going to the mapping and setting the scale to 1 or maybe 4. The result looks good, and I can make some more adjustments to the color map like this. The result is looking good so far. I can adjust the noise scale to be higher or lower, like 10 or 8. I think 8 works best, so I'll use that. The first material is done, and we can tweak it later if needed. Now I'll follow the same method for the other materials. Next, I'll begin with the material for the outer wheel rim. I'll go back to the previous material, select all the nodes we added, and copy them. Then I'll go back to the wheel and paste them. I'll connect the mix result to the base color. Great, now I'll adjust the colors in the color maps here and here. I'll change this color to pink, hover over it, and press Ctrl plus C to copy. Then I'll go to the second color map, hover over the color, and press Ctrl plus V to paste it. See how the result has changed. I want to make the material a bit shinier, so let's set the roughness to 0.3. Now I want to invert the two colors. First, I'll switch the coordinate from object to generated and connect it to the mapping node of the noise to achieve a better result for the material on the element. Next, I'll go to the color map of the gradient and invert the two colors. Now, I can adjust the color values in the color map as desired. I'll set the pink color to 0.5 on the slider and the beige color to 0.6, for example. The result looks good and I find it suitable. Let's see what happens if we change from generate to object and connect it to the mapping of the gradient. You'll notice that the gradient becomes a bit harsh. That's why I'll revert the connection back to generated as it was, and we'll find that the gradient becomes smoother. I want to make some changes to the material here and adjust the noise size. I'll set the scale to 5 and the details to 0.5, leaving the other properties as they are. I'll see what works best and change it freely. I might go and tweak the color ramp a bit. Notice that if I increase the pink color value, you'll see the noise details on the shape become more subtle. The closer the two colors are, the more details we have. I might also adjust the second color ramp slightly. I can then go back and tweak the scale in the noise node, setting it to 10. You'll notice how the details change. Next, I'll adjust the lighting in the background here. I'll switch this window to 3D viewport, hide the sidebar and toolbar, exit the camera view, enable the overlays, and then switch to the top view. Okay, now I'll press Shift plus A and add an area light. I'll scale the light a bit, then switch to the front view and rotate the light 90 degrees. And move it on the x-axis, G plus X, at the start of the scene. And move it on the z-axis, G plus Z, to lift it up, then align its direction to the wheel. Grab it from this point and drag it towards the wheel. I'll switch to top view, rotate it on the z-axis, R plus Z, by around minus 25 degrees, then drag it on the y-axis, G plus Y. And I'll make a duplicate of it, Shift plus D, rotate it and drag it in the opposite direction, then using G, I'll move it a bit closer to the shape and rotate it again with R so it points towards the wheel like this. The lighting still looks almost the same, so while selecting the light, I'll go to its properties here and set the power to around 1000. Now the lighting looks better. Then I'll select the second light and increase its power to 1200. Notice how the lighting now looks much better. I might adjust its position a bit. Next, I'll check the first and last frame to make sure the lighting is correct. I'll notice that the first frame looks fine, but in the last frame there's a shadow showing up. To fix this, make sure I'm on the first frame, then I'll go to the outliner, select both lights, then hold Shift and drag them onto the dolly empty. Now, after parenting it with the dolly, I'll check the result on the first and last frames, and I'll find the result matching perfectly. Okay, now I'll go to the outliner and move the light from this collection to the camera collection for better organization so their display icons will appear here. Now, I'll go back to the shader editor and make some adjustments to the material, tweaking the colors and noise scale until I get the result I'm aiming for. This is the result I've reached. Now I'll name this material Wheel and the inner part Wheel Inner. Next, I want to apply the same Wheel Inner material to the arm. So I'll select the arm, and instead of creating a new material, I'll go to the drop-down icon here and choose the Wheel Inner material. I'll notice that the same material has been applied to the arm. Now I want to add a material to these two parts. I'll select one of them, create a new material, and name it Metal. And I'll drag from the base color and search for color ramp. Or by pressing Shift plus A to add the color ramp node. And press Shift plus A again to add the gradient node. While the gradient node is selected, press Ctrl plus T to add the texture coordinate and mapping nodes. And I'll connect the output of the gradient node to the factor input of the color ramp node. We will see the result of the gradient on the object like this. Then we can adjust the black color and either change it to green or add the hex code. I'll make some slight color adjustments here like this. Maybe try switching from generated to object. Looks good, I'll stick with this. I can also tweak the color ramp if needed, depending on what looks best. I'll go to the principled BSDF. I'll set the metallic value to around 0.2. I'll also set the roughness to around 0.2. So, I get a material that has a subtle metallic look with a slight shine. I'll set the roughness to exactly 0.2. Now I'll apply the same material to the second object. So I'll select the second object and apply the material to it. And this way, we've applied the same material to the second object easily. Great. Now I'll select the hook to apply the material, and I'll make sure it's selected by enabling the overlays. I'll zoom in on the hook in the viewport to make it clear. Then I'll click New and name the material Hook. If you can't see the material, press A and period on the keyboard to frame it. And to save time and avoid adding the nodes again, I'll go back to the wheel material, select all the nodes, copy them, then go to the hook and paste them. I'll modify the color ramp and choose a brown color here. Then I'll connect the color ramp to the base color to see the changes. I'll copy the hex code of the brown color and paste it into the color ramp here. I'll tweak the noise texture a bit and set the scale to 5 to get a different result. And I will set the details to 1 and the roughness to 0.5 and set the lacunarity to 0 and the distortion to 5. And I'll tweak the mapping. I'll set the scale to 5. This is the result I got. I can try changing the texture coordinate from object to generated, but it won't look right on the object, so I'll switch it back to how it was. I'll zoom out in the viewport here and hide the overlays. I can also go to the View menu, then to Camera and choose Frame Camera Bounds, or use the shortcut Home. It frames the camera view inside the viewport. I'll go to the last frame to select the second hook and make sure it's selected by enabling the overlays. Then I'll go to the material icon, and from the drop-down I'll choose the hook material. This way, I've applied the material to the second hook instead of creating a new one. Hide the overlays in Gizmo again, then make sure the first and last frames are matching. Great, the result is excellent. Before continuing with the rest of the material, I'll enlarge the viewport by pressing Ctrl+Space to get a better view of the scene. Then I can go to the View menu, select Camera, and choose Frame Camera Bounds. I'll exit full screen by pressing Ctrl+Space again. Now I'll continue creating the material for the remaining objects. I'll select the wall, click New, and name it BKG. If the material doesn't appear, I'll press A and then the period key on the numpad to frame it. For the base color, I'll choose a green color or add this hex code, or I'll press Shift+A to add a color ramp, then add the hex code here and here. I'll set this color here, tweak it a bit. Then while the color ramp is selected, I'll press Ctrl+T to add the mapping node and the texture coordinates and delete the image texture because I don't need it. I'll link the generate to the vector mapping instead of using object coordinates. I'll exit the camera view and enable the overlays. Then I'll select the walls without a material. And finally, I'll select the wall with the material and press Ctrl+L. Then choose Link Materials. Now all the walls have the same material. I'll go back to the camera view and hide the overlays. I'll continue creating the material, select the bridge or the floor, click New, and name the material Bridge. For the base color, I can choose a color or add a hex code and adjust it as I see fit. For the roughness, I'll set a value, for example 0.3. As we see here, it looks good. Now, I'll create the material for the underground. I'll select the wall, then drag the material from this icon and drop it onto the underground. The underground will take the same material. I'll enlarge the window by pressing Ctrl+Space. Then go to the Render menu and choose Render Image. For a quick preview of the render. The result is great. I'll close the window and exit full screen mode. Now you have the freedom to adjust the animation and materials as you see fit. The last step I need to do is check the first and last frames of the animation to ensure they match. Also, I'll check the lighting on the first and last frames to see if there's any difference. The result is perfect. Now I don't need the shader editor, so I'll hide it. I'll then go to the last frame of the animation, subtract one frame, making it 55 frames, to avoid double frames, ensuring a smooth transition and preventing any jerky motion in the animation. To view the animation smoothly in the viewport, I can apply the modifiers. I'll select all the walls, go to the Modifiers tab, press Alt then Apply. You will see that all the modifiers have been applied to the walls. Now I'll speed up the video and apply all the modifiers that I don't plan to modify anymore. Of course, make sure to save the file before doing this. Now I've applied all the modifiers. I'll return to the camera view and I'll hide the overlays in the gizmos and enable the render view. Then I'll bring back the frame we temporarily removed to check the first and last frames through the render. I'll do a render image from the Render menu. The render for frame 56 will appear in the first slot. I'll switch to the second slot from here, go back to the first frame, and do a render image from the Render menu. Then I'll toggle between the first and second slots to check if there's any difference between the first and last frames. This way we can ensure that the loop is seamless and the lighting and material are correct. After that, I'll remove the frame we added temporarily and we can start with the render settings. In the Render tab, I'll make sure that in the color management the look is set to high contrast and the view transform is set to AGX. The higher we set the look, the better the result, but I'm happy with this one. I'll go to the Output tab and make sure the resolution is set to 1080x1080 for the correct video size. The frame rate is 30 frames per second, and the start range is from frame 1 to frame 55. I'll also set the output location and name it Animation Loop, then click Accept. The file format will be PNG, color set to RGB, color depth set to 16, and in color management I'll select Follow Scene to match the render settings. With this, we're ready to render the animation, but I recommend turning off Render View here to avoid slowing down the system during the final render. Then I'll go to the Render menu and choose Render Animation. Now all frames will be rendered, and I can monitor them by holding Alt and clicking the folder icon to open the output directory we selected. Once rendering is complete, I can combine the frames inside After Effects or Blender itself, which is what we'll do. After finishing the render, I'll save my Blender file, then go to File, New, Video Editing. In the Sequencer window, I'll go to Add Then Image Sequence, select the folder where I saved the frames, press A to select all the images, and click Add. Now that all the images are added, I'll adjust the end frame to 55 so that the timeline matches the animation length. I'll make sure the frame rate is 30 frames per second, and the preview window resolution is set to 1080x1080 for the correct video size. To export the final video, I'll go back to Output, set the file format to FFmpeg video, go to Encoding, set the container to MPEG-4, video codec to H.264, and output quality to high quality. Then I'll select the output folder, name the file Animation Loop Final, and finally go to Render Animation, or press F12. The video will render quickly, and when I check the output folder, I'll find the final video ready. This is the result we achieved in this lesson. I hope this tutorial was helpful, and stay tuned for future lessons. See you next time.